So this is the POTD for today. So here what we have to do is we have to print the sum. Okay, so that would be 1 plus 3 plus 5, which is 9 over here, right? And then 2 plus 6 plus 4 plus 7, and then 9 plus 10 plus 11 plus 12. Okay, so here you have to observe one thing that see in the first section whenever I am at some particular node, okay, I will start from here. Now, you definitely know that 1 will be there in the answer. But if you see, 1's right is also there in the first answer. And then 3's right is also there in the first answer. Okay, so that is the first observation that we will do. The next thing is 1's left will be in the second uh, iteration, right? Third's left will be in the second one. Okay, now 5 does not have any left, so it will not be there anyway. Okay, so for the first iteration, we will have 1 and its right nodes. Okay, and for the next ones, for the next iteration, we will have 1's left, 3's left, and so basically that is 2 and that is 4. Okay, but each and every node that you pick up in that particular iteration, you will also take its right. You will also take its right. Okay, so that is how this whole thing will actually work. Okay, so let me just make this easier for you. So how we will do this is, okay, I will start with something like, Q1 and Q2. Okay, so in the Q1 I will just put the first element. Okay, now in each iteration what we will do is, so for the first iteration we will keep on doing till we don't get Q1 as empty. So what I will do is I will take this node, I will just push it out of the queue and I will add it to the answer. Okay, or maybe we can call this as some current sum. Okay, so the current sum is 0 and I am adding it to the answer, so that is +1. Okay, now make sure that you also add its right in this particular Q1. Okay, why? Because Q1 is basically all the elements that you are going to consider to add to this current sum in that particular iteration, and Q2 will be all the elements that you will be taking for the next iteration, right? So this is Q1. So we are taking this one, and as I said, you will take its right node also in the same iteration, right? And the left node in the next iteration. So what you will do is once left, you push it in the Q2, and once right, you can push it over Q1, correct? So again, we are iterating through Q2. So again, take out the element which is there and add it into the current sum. Again, 3's right, you put it in the same Q1, and Q's left, you can put it in the next iteration, right? To be considered in the next iteration. Okay, and then just pop out 5. Okay, and you can see it does not have any right, so we will not add any element to Q1, and it does not even have any left, so we will not add any element to Q2 also. So here you got the first sum, which is 9. Okay, so that is for the iteration number 1, or we can say for the diagonal one, we got a sum of 9. Okay, now what you do is make Q2 as Q1, because these are the next elements that we will be considering for the next iteration, correct? So let me just erase them. So you can take these sums. So basically we had 2 and 4. Okay. Again, let the current sum be 0. Pop out the 2 and add its right in the same iteration. Okay, because we are going to consider that particular element in the same one and add its left in the next one. Okay, to be considered in the next diagonal. Okay. So here, as we have taken 2, we will just do a +2, right? Again, for the same thing, 4, you know, you do a +4 and add the 4's right to Q1 and 4's left to Q2, correct? Take out 6, okay? 6 does not have a right, so we will not add anything to Q1. And in the Q2, we will add 11, okay? So here, 11, correct? And add 7, okay? So 7 does not have any right nor left. So this will be the total sum for the diagonal 2, right? So that will be diagonal to sum, which is actually, you can see it is 2 plus 4 plus 6 plus 7. So it is like 2 plus 4 plus 6 plus 7, correct? So what is that? I think 6 plus 4 is 10, 12, 12 plus 7, right? Which is 19, right? So that is 19. Again, Q1 is empty. So now again move to the next iteration. So we have completed one diagonal over here. Okay. We will move to the next iteration, which is, I think we had this 9 and I forgot actually. So we, I think, had the left ones, right? So yeah, we had this 9 and 11, correct? Now take out 9 and add the 10 in the same direction. I think we also had 12, right? So because it has the left one, right? So we will again take the current sum was 0, again plus 9, right? So we consider 9 and we put the 10 in the same iteration. Again take out 11, again take out 12, and you know, and again we also added 10, so we will also take it in the same iteration plus 10. So you can see in the next iteration all these elements are going to be used. So that will be 9 plus 10 plus 11 plus 12. Okay, so that is how we are going to solve this. That is the basic logic, right? So the logic is, in the Q1 we will add all the nodes, that node plus all of its right elements, and in Q2 we will add whatever node that we are considering its left ones. Okay, and finally when we process the whole Q1, we have the diagonal sum for that particular diagonal, right? And after that, this is the next diagonal to be considered. So we will just do a Q2 is equal to Q1, and then we will empty out the Q2, right? So that is the whole logic for this thing. Now let me just show you the code for this so it makes it more clear. So you can see that I have taken this Q, like two Qs, Q1, Q2, and I have started with the first node, which is root, and I have taken an answer. Okay. So while true, so this is for one diagonal that I'm trying to do, right? For one diagonal, I'm taking the current sum is equal to 0. And when what is one diagonal? One diagonal is till you have the elements in the Q1, right? So I will take all the elements and I will just add it to the sum. And as we said, the node left, whatever the left child is, I will take it as a part of the next queue, or maybe as a part of the next iteration or the next diagonal, and Q1 as a part of the same diagonal. Okay. And once you have taken all the elements or processed all the elements in the same queue, you will just take that sum and put it into the answer. So that is for one diagonal sum. Okay. Now you have to just update Q2, right? So Q2 is like if Q2 is empty, if so after this 9, 10, 11, 12, you will not have any elements in Q2. Now at that point you can just stop. So that is why break. Else you will just update your Q2 to be the next Q1, right? So that is the next diagonal to be processed, and just clear the Q2, right? So that is the whole code, and just return the answer finally. So this is an order of n solution, right? Which takes order of n space and order of n time. Okay, thank you.